Okay, 13.5, very last section of this unit. We're not going to have a test on it. It's just going to be quizzes. We're talking about independence. So independents aren't affected by other events that happened before. So that's what independence is. So if you're independent, you're not getting affected by things. So you can either use intersections to figure that out, or you can use conditional probability. And whichever one you do, there's a different formula for it. So this is the first formula if you don't have any conditional probabilities. And these are the two formulas you can use, either one, if you're given conditional probabilities. So like this first example, we're given an intersection. So we're going to use that first, the first equation. So to test for independence, I set up PA times PB equals the intersection. Make sure that's the intersection when you do it. So I go through and solve this. I get 2 over 20 equals 1 over 10. If I simplify them both, I get the same number. So they are equal, which means if they're equal, they are independent. So you write independent, or you write yes, something like that. And you have to show that step of equaling each other the same. So those are pretty easy. Let's look at the next one. This one is using a table to get it. So what's the probability of your gender and how you get to school? And this is going to be different for each person. So like for me, I'm going to say, okay, I'm a girl, so the probability of female, I need to know if that times the probability of getting to school, and I go by car. I get here a little too early to use the bus or walk, that'd be a little far. And I want to see, okay, do they equal where those intersect? So female intersecting car. Now, if you're doing this and you're a guy, you might use the male instead. And you should see on your own if it's independent. So for me, female, the total females is 403 out of our total study. Remember, don't use the conditional since there's no bar here. And then my probability of a car is 351 out of 797. And the probability of intersecting is 185 out of that 797. And for these ones, it might be tricky to get these to be nice, pretty numbers. So let's just get the numerators here. Really big number. That's totally fine. Denominator. Let's see if we can get that as a decimal and as a reduced fraction. Yeah, so these aren't going to give you reduced fractions, so it's fine to just get the decimal of them. So what I'm going to do is make sure I keep lots of decimal places to do this. So I get 0.22269. See how many decimal places I took? I'm going to do the same thing with the other side to see if they're the same. 0.23212. And if you notice, even though the first decimal place is the same, the second one is not. So they're not equal, which means they are not independent. Which means that if you're a female, it affects whether or not you take a car. That's what it's basically saying. So those are your two different kind of, we use the same equation because intersections pop up more than conditionals. But the two different ways of solving the problems, either with a table or with just given information. And that's it for 13.5. Make sure after you finish the homework for this that you take the quizzes for all of Unit 13 before you move on to Unit 14.